In this video, we're finding the sum of a geometric series that goes on forever. And before any formula, look at these two. Both of those go on forever, but they do completely different things. Take the top one and keep a running total. 1, then 1.5, then 1.75, then 1.875. It's creeping towards 2, and it is never going to pass it. Now the bottom one. 1, 3, 7, 15, 31. That one just runs away. It has no total. So what separates them? It's the common ratio. On the top, r is a half. On the bottom, r is 2. If r is a fraction between -1 and 1, each term is smaller than the last. The terms shrink towards nothing, and the total settles down. Otherwise, it doesn't. Here's the formula. S infinity equals a1 over 1 minus r, and that condition written next to it is not optional. The absolute value of r has to be less than 1. If it isn't, this series has no sum to infinity, and writing a number down is wrong. Not just inaccurate, wrong. Let's check it on the one we were just watching. 1 plus a half plus a quarter, and so on. A 1 is 1, and r is a half. 1 over 1 minus a half. That's 1 over a half, which is 2. Exactly the 2 it was creeping towards. Example 1. Find the sum to infinity of 8 plus 4 plus 2 plus 1, and so on. 4 over 8 is a half, so r is a half. That's between -1 and 1, so we're fine. 8 over 1 minus a half. 8 over a half. Dividing by a half is multiplying by 2, so that's 16. Example 2. Find the sum to infinity of 9 minus 3 plus 1 minus a third, and so on. -3 over 9 is -1/3, so r is -1/3. Now the absolute value of -1/3 is a third, which is less than 1, so this one converges too. 9 over 1 minus -1/3. 1 minus -1/3 is 1 plus a third, which is 4/3. 9 divided by 4/3 is 9 times 3/4. That's 27 over 4, 6.75. Example 3, and this is the trap. Find the sum to infinity of 2 plus 6 plus 18 plus 54. R is 3. And the absolute value of 3 is not less than 1. So there is no sum to infinity. This series diverges, and saying so is the correct answer. What you must not do is put it in the formula anyway, because if you do, you get 2 over 1 minus 3, which is 2 over -2, which is -1, and that is nonsense. Every single term in that series is positive. The total cannot possibly be -1. Example 4. Now working backwards. A geometric series has a first term of 5 and a sum to infinity of 20. Find r. 20 equals 5 over 1 minus r. Multiply both sides by 1 minus r. 20 times 1 minus r equals 5. Divide both sides by 20. 1 minus r equals 5 over 20, which is a quarter. So r equals 1 minus a quarter, 3/4. Last one, and this is a classic. Write 0.4 recurring as a fraction. The trick is to see it as a series. 0.444 is 0.4 plus 0.04 plus 0.004 forever. And that's geometric. The first term is 0.4, and each term is a tenth of the one before, so r is 0.1. 0.4 over 1 minus 0.1. That's 0.4 over 0.9. Multiply top and bottom by 10. 4/9. And check it on your calculator. 4 divided by 9 is 0.4444. Geometric sequences aren't just an exam topic. They're what money does in a savings account. Next video, compound interest.